Welcome to the Crescent Method. Today we have a very different show for you. We've got a special guest on that we'd like to introduce to you. His name is Adam Swan, and he is from the UK. He is a trained soil food web advisor from Dr. Elaine's Soil Food Web School, and he works with the Soil Ecology Lab as well as Soil Smiths in the UK. So we're going to bring on Adam and
Which
have
I
him.
which I learned today. The UK is not Europe. It's
No,
not the same thing.
not the same
I
thing.
don't know. I came from California. That's where Disneyland is.
Used
People
to
come to
be.
see us. I don't really know. But without further ado, let's
Yes.
bring on the homie Adam Swan as part of the new segment on Science Bro called The Network, where we tap in with other soil food web advisors that are doing the damn thing, changing the world, fixing the soil, saving your life, whether you know it or not.
Yeah. So
That's
tell us a little bit
something
more
about
about
that.
your background and, what you've been up to.
Cool, yeah. So I've been at this for a few years. I come from had a really cool permaculture experience, like nearly a decade ago now, where I went to Peru, got to see agroforestry in the Amazon, 172 hectares, which was amazing. That really inspired me to just get involved with this stuff and look for projects to work with and try to become more sustainable, more sustainably minded, more conscious of my impact on the world, and to interact in agriculture. For my adult life, I've been a professional musician, so I'm kind of new to this. I didn't grow up in agriculture, although I grew up in the center of agriculture for the UK. I didn't grow up on a farm or anything. I don't have no agricultural experience. I'm kind of happy about that now. I know about agricultural
Yeah.
experience, being around poisonous stuff
Yeah.
and chemicals and big machinery and all that. So yeah, so then I went on to market gardening. I traveled in Portugal, worked with market gardeners. Always wanted to start a market garden. Looked around the UK for market gardens to get involved with. Wasn't so impressed by the approach, or didn't feel like it gelled with how I wanted to run things myself. So I set out to start my own market garden. I started looking for compost, and then I found out that compost didn't really work like people were advising to use it. Like, you grow plants in compost, well, commercially available compost,
Right.
and things start to go awry. I tried mushroom compost, green waste, yada yada yada, all the different types. And like most people, I find out that most of it's pretty bad. So I start looking into compost. How do I make my own compost? How do I, manipulate cheap things around me, like resources, to make the thing that I need that's central to a market garden? And that led me to Dr. Elaine Ingham and her school, and the list of people, the little lab tech list, or consultant list. I looked through there and I looked at all the people in the world, and I started to look into those people. And just so happened that the guy, her first student in the UK, happened to live not even, like not even 10 miles away from me. And he was the only guy on that list in mainland UK. And
Wow.
I was just like saying to my girlfriend the previous week, like, ah, shit, I'm never going to find anyone. I'm never going to find anyone that cares about this stuff, that can
Mm.
teach me. I'm never going to have a community of people. And I was just, moaning and depressed. And then turns out that the only guy on, the island is 10 minutes away. So that was cool. So I turned
Awesome.
up at his place and I was like, you need to tell me about this stuff. You need to show me this stuff. I need to volunteer here. And he was like, I'm not really looking for volunteers. I want to make this into a commercial thing. I'm looking for employees. And I was like, well, yeah, you can't pay me yet, so I'm volunteering. Like, I'm here to make some
We're
compost.
doing this. We're doing
Yeah.
So I
this.
started throwing down compost. Like, I'd had some experience making compost with like just manures. And you know how that is. It
Yep.
gets extremely hot and it's extremely stinky sometimes. It gets extremely anaerobic, and it's just not really the ideal input for a good compost, although it's a resource that's widely available, right? So
Sure.
Yeah.
yeah, I was making compost with that, making biochar, and heard about terra preta and all that stuff. So get to soil ecology lab, and I was ready to just absolutely throw down making compost. So over the course of the last, nearly 3 years, um, I've only really made 50 piles. But you can make 50 piles and you can like
Only?
make 50 piles, or you can make 50 piles and you can look at them, right? And you can
Right.
write stuff down. And if you do that, even just making 10 piles is an experience, right? A real learning curve and a real cool experience with observational hands-on science. So
Yep.
yeah, started doing that. We started with static composting. The Johnson Su method was, lots of people were talking about it. It was online. He had these fresh presentations talking about, different research that he'd done into using that material. And the idea of a static pile to me seemed to make sense, right? Seemed to make sense that a static pile might be less disturbed, might success towards fungi. You might get a fungal compost out of it. So we started playing around with them. And that was really interesting. I did about 25 of them, and now we've done 25, or yeah, on to 26 now of the thermophilic compost piles. So it doesn't sound like a lot, but you can learn a lot from that experience. And
Exactly.
Daniel teaching me how to use the microscope. So Daniel was one of Elaine's first students in the UK. He had a community of people that he knew in Europe, and in the UK. And so they taught me how to basically use the microscope, um, and then we did, right. We tried all the soil food web stuff. So then we scoping extracts, trying to understand what's realistic. What can we manipulate in those systems to provide um, provide some kind of value for crop support, and for
Yeah.
the desired effect, which is at the end of the day mostly to grow plants. There's some other things, but mainly to grow plants.
Right.
So now, 3 years ahead of time, um, fertilizer prices are rising really rapidly, and
Yeah.
people are looking at people like us now for answers. And we have limited answers, but we have some answers, and some practical knowledge, um, and we know the limitations and the benefits of using these systems.
Yes.
So that's where we're at now, and lots of people have started to get really interested in it. You know, um, I think Elaine's presentation at the Oxford Real Farming Conference is the most viewed video they have. You know,
Wow.
and I'm sure that's down to the cannabis community in part. People from the cannabis community finding about the soil food web and go looking, they go looking for Dr. Elaine Ingham, and they find that talk, which is a pretty cool talk, really good intro. So
Yeah.
yeah, so now we're working with well, first of all, we did 2 trials ourselves on barley and wheat. Um, we made all the biocomplete compost, right? We dialed that in, and my boss Daniel is really dead set on using the biology to create a system for farmers that's reliable, predictable, even as predictable as farming can get, and achieve an outcome that basically is reliably as good as conventional farming with better quality produce, right? And try and match those yields, or at least make it financially the same, right?
Yeah.
Um, and so that's what we've been aiming to do, which has been a really cool, amazing, experience. Trying to understand how to grow a grass in a really, retarded environment, um, with with only the power of microbes from compost, right? So
Yeah.
it's
Wow.
Nice.
it's been incredibly interesting. So,
I would say
and
50
now we're
piles is,
starting to grow wheat in a grow tent.
yeah.
Madness.
Yeah.
I would say 50 piles is a ridiculous amount of
That's
hand turned
pretty good.
compost piles along with other things. So man, there's very few
Yeah,
people
most of them
making,
were 1,000 liters of parent material as well. I was like
Oh
super
yeah.
into it, and now they've gone down to about 600 liters of parent material per pile. So I think that's a good place for people to start. 600 liters of parent material. It doesn't compact too much. It's big enough that it's worth it. It's
Yeah.
kind of a
yeah,
happy human-sized pile. A
yeah,
thousand liters can be done, but it's good if you got some friends.
yeah,
Right. Right.
right,
Exactly.
yeah. It is. Friends are important. So I think most people get pretty discouraged around 2 to 3 piles. Sarah's had some mentorship students back in the day that would get 10, 15 piles in and still not have success. And one of the things that you mentioned that we are absolutely advocates of is documenting something of your process so that you can learn through this experience. And it's very easy, I think, especially in the composting process, to get completely lost in the sauce, so to speak, and really go through a tremendous amount of effort oftentimes. Like when we lived in the suburbs, just getting a load of wood chips was quite the ordeal, you know? And so oftentimes going through extreme levels of effort to even start this thing, and then the amount of effort to get through it and then not have it be successful and have no clue why. I think that's, if you take no other big takeaways from this interview, please, take that. And one of the reasons why we've, enjoyed talking to Adam so much is he's very similar to us. One thing that I really enjoy about Adam is the same exact thing that we did when we started with these capabilities, Adam has done. So if the popular trend is taking XYZ product and using it in a certain fashion, and everybody just accepts that. And we were the type of, well, let's use this microscope to see what is happening. And that's far more rare than you would ever imagine. And when we first started talking, you were describing some of the little tinkering experiments you did. I was like, wow, this is like the fourth soil food web advisor we've met maybe that goes through this process. And the reason we got to the level we got so quickly is, well, one of the reasons, there's a lot of reasons, but one of the main reasons is if you're a soil food web advisor and you have functional experience with the popular trends, when you show up to a farm that's executing these popular trends, you already know what the deal is. You already know what's going down, And so it's very easy to identify the weak points in a popular trend when you use the microscope to analyze that process. And at least when we went through the consultant training program with Dr. Lane, she coaches you right on through some basic functional strategies for analyzing products, so to speak. And we're going to save an entire episode for just that, so I don't want to get too deep into that. But do you want to maybe mention some of the interesting things that you have done, or maybe some of the interesting learning
Yeah, so
experiences? I mean, you've done some wild shit, brother.
Yeah.
You know?
yeah, so I mean, I've been really fortunate that um, we got funding, right? Daniel got funding, so I get paid to go to work and do this. So you got to do something, right? And if there's one message from Elaine, like you say, it's write it down. Like if the soil food web course means anything, it just means write it down. Like write
Right.
everything down, um, and make observations. Look at soil chemistry, look at soil biology, use as many tools. Go out into the field, count blades of grass. You know what I mean?
Yeah.
Like do something,
Yeah.
because you're going to find a story if you do that stuff enough.
Right.
You don't need to know what you're trying to find out to find something out. It's super
That's
important.
that's a good point.
So yeah,
Mm-hmm.
really, really, that's what's going to take you from being based in theoretical knowledge from the internet and into actual
Right.
functional stuff. That's the
Yes.
stuff that gets shit done.
Yes.
So yeah, so testing. Wow, we've done a lot, right? We've done a lot.
Yeah.
So we're trying to develop this project that takes the soil food web. We use the compost as a bioincubator, um, and then we try to create that biocomplete compost. Then we try to extract it and concentrate it into a form where it's stable, with no additives really, and so we can ship it around without the associated weight of shipping compost or shipping water, right? So it's just the concentrated soil food web in a kind of jelly or in a slurry state, in a solid state, but not really in like a watery. We're trying to move away from watery nutrients and get them ripped off. So
Yeah.
um, yeah, so we have to quantify that process in itself. That has been a huge amount of writing stuff down, um, and then using the bioassay and the biocomplete compost as a tool. So as a biological reference that you can get used to measuring, you can get your numbers laid out, you can sit back and look at them, you can apply something, an input commonly talked about on the internet, and then you can see a response, right? You can see a response in 24 hours and 72 hours and 40, like you can take as many data points as you can, and then you can sit back and look at that data and you see a story about that input. You see a story that goes into the bacteria, and then the bacteria respond, and then you see it go into the flagellates. Flagellates respond. Later, you might see nematodes respond over a slightly longer period of time. Then you're going to see like fungi respond over a much longer period of time. Generally, I find,
Mm-hmm.
right?
Yes.
Everyone's going to find different stuff. Everyone's in a different environment, but it's important that you have that reference point for running your shit, because your shit makes you money, right?
Right.
So
Yes.
So looking at Ascophyllum nodosum seaweed kelps, it says on the bottle, like a kelp extract, it says boosts microbes, prokaryotic, exploder, something. It says something, right?
Right.
So
Right.
find out what if that's true or not. Does it,
Right.
does it influence microbes, or does it kill microbes, right?
Yeah.
Because you want it to basically, on that bioassay, you want it to, if it's a biostimulant you want to use for your plant, you want it to do nothing, so it doesn't destabilize, it doesn't damage, um, it has no effect basically on the microbes, or you want it to have a positive effect that doesn't basically boom bust destabilize the
Right.
population, right? That would
Yes.
Right.
be nice, I think.
That would be
I think
nice.
that's a
Yes.
useful tool. So
Hmm.
that's
Do
what we use to dial in practices. um, yeah.
Do you want to
If
explain what the
Elaine taught you
boom?
anything, it's the,
Oh, go ahead. Yeah, go ahead. I
yeah.
was just gonna
Sorry,
say if
there's a
you wanted
little bit
to.
of delay, but if
Yeah.
Elaine taught you anything, it's to not practices. She doesn't teach you practices that are going to run your farm. She teaches you how you can figure out how to run your farm or your project, right? I think that's really empowering. And so, yeah, just wanted to say that.
That's
What
well
were you going to
said.
say with the?
I was gonna say, do you want to explain? Yeah, that's a really valid point. I think people really misunderstand what Dr. Lean is trying to communicate and what you get out of the school, and it's a functional system for analytics that allows you to guide any part of your process. I mean, we've used the microscope assessment uh, to drive everything from, or to analyze and then modify anything from employee behavior, farm practices, watering frequency, content, volumes,
Pattern recognition of
pattern
just what's happening.
recognition.
Yeah.
Yeah, the pattern, I really like patterns, and I feel that that's something that we're quite good at. And the microscope allows you to paint the picture of what that pattern is so then you can start to investigate it. One
But
of the,
this, oh,
yeah,
go
go ahead.
ahead.
No, you go.
But this just points to what we talked about on last week's episode, is that it's not, it's more than just being able to identify each of the individual microbes. It's actually putting it together in a story, in a pattern. And that bioassay is really what shows you that pattern. So, yeah, it's crucial to be able to figure out what's actually happening and what needs to be happening. If you don't have that tool, it can be, well, you can't really figure it out really
Yeah.
much. I mean, I guess there are
Yeah,
other
people
markers,
say
but
they talk about how a, a certain lab tech could be different to another lab tech, right? That is definitely true. There is some
yep,
truth to that. We've seen it in our own lab. Some people are a bit more overestimate, they overestimate fungi. Some people stay a bit more reserved. But when it's in your hands, when it's your microscope, it doesn't matter really. It just, what matters is the changes
Right.
in that, and you just have to make sure that you're consistent, and then you are the metric for yourself, right? So
yep,
that's the super empowering thing. If people can be bothered to get a microscope and look down it, it's well worth it, as a farmer or a grower, any
yeah,
anyone working with plants, or maybe other stuff too, like
Yeah.
cleaning stuff up, regeneration of land, decomposing hydrocarbons on buildings and stuff like that. There's lots of applications for these microbes beyond agriculture, but Within
Yeah.
agriculture, it's now essential, I believe, that we do this, right? Essential.
Absolutely.
I would agree.
Absolutely.
I would agree.
Yeah.
It's the only way out. So,
Only way to really pull out those minerals and really get them into the plants and
yeah,
into you is through that connection.
yeah.
So,
What are some of the interesting things you've done? So, like we've had a lot of conversations about DNA testing, which is not accessible to most people. We've done a lot of analytics and have definitely started to shape agriculture in our sector. The only other person I'm aware of that's doing DNA testing is Nick Tomasini, and I would think that you've done more than anybody I've heard of. Have you learned anything interesting? And again,
Well,
I think this can be an entire
okay,
show,
yeah.
but
So
give them a little morsel.
yeah, I'll talk about for like just the DNA process for a bit. Like we've worked with it. Um, it's just like microscopy. It's just like a refractometer. It's just like plant testing. It's limited, but it's also a metric, right? You can look at it. You can ponder over it. You can line it all up over a period of time or a project, and you start to notice things. You have to look at it. You know, it's just like farmers that get soil tests. They don't. I don't know what they just put it in a cabinet somewhere. Like,
Mm-hmm.
um, so, but yeah. So it's not like microscopy in the fact that you're seeing what's alive in front of you, right? When we use microscopy, it's active biomass, and counts for the stuff. It's really there. Whereas when you're looking at DNA, that thing could be dead and it was just its leg there, and now
Mm.
we got a DNA signal off that. But still, yeah. So we're working with a tree nursery to try and make a regenerative tree nursery, basically, where they won't use plastic. So they'll use a paper pot system, and then they want to develop a substrate and an inoculum to kind of treat that substrate. So we've used DNA to try and understand different composting processes. So thermophilic composting, Johnson-Su bioreactor composting, worm composting, where it's more shallow and in trays or beds, um, and then just kind of interesting folk around the UK that so there was a guy who did the Jean Pain method compost pile where you heat up water and they were running a shower off compost piles.
oh
So
yeah,
we tested that for DNA because it's slow and long, and I guess it's quite wood chip heavy, so maybe not so much, but maybe a little bit anaerobic. It
yeah.
gets quite hot and stays quite hot for a long time. But anyway, we did that, and we did so there's this guy called Ian Tolhurst he's run a veganic kind of market garden in the UK. Well, they call it stock free, right? So without livestock in the UK since the 70s. He just accepts, I think he accepts wood chip from like wood tree surgeons, gardeners. It comes to his site, he ages it for I think for at least 2 years, and he uses it for a propagation mix, and it builds up, and then every 7 years, I believe, in his rotation, he puts on his compost. So it's made of types of trees that are maybe really aromatic, the kind of trees that's like a fast growing hedge. People chop them down because they grow too fast. They plant them,
Right.
they don't know what this tree does. They don't know it's from like the the Pacific Northwest, and it's going to grow into this massive thing, and then it does. So they chop it down, and then they send it to a composter, or send it to Tolly. So he like stacks it all up and composts it. I think he does maybe turn it, but it's not like like Elaine teaches with a kind of precise method for thermophilic composting. It's
Right.
more kind of long term, but still turned a bit, and then sieved. Yeah. So, but it's very, very, very wood chip heavy. Um, and so we saw the different microbial communities within these different composting groups, and we started to notice cool things. So in my pile, where say I'd added kelp meal, I got like a what was it like an arsenic oxidizing, an arsenate oxidizing um, bacteria, and I think that's probably from the inclusion of arsenic maybe coming from the kelp, just a guess from me. I don't have any. That's not exact, but I used kelp in that pile. We got that microbe. Then the John Pan method had a hose wrapped up in it,
Right.
120 meters of hose, and we got a plastic degrading bacteria in that one. Right, we had 120 meters of plastic hose in it. So,
Interesting.
um, it
Fascinating.
seems like the compost piles can be used and steered. You can use them as a bioreactor to select for things that are useful for your application by the inclusion of that thing. So if you need to bioremediate, you should think about maybe adding some of the soil that contains the contaminants into the composting pile. So then you can train the microbes to deal with those contaminants. You can select for microbes that deal with those contaminants. So then when you put it out on the land, you've got a cheap way of culturing microbes that deal with the contaminants, basically.
Yeah.
And
Awesome.
so it goes the other way too, right? Like optimization for building ecology, for crop support, complete and balanced and abundant ecology in the material for nutrient cycling and all that good shit that it does. So, um, yeah, so we've seen some really interesting stuff, and yeah, we can definitely do that in a future episode. I think it's worth um,
Yeah.
doing a whole episode because there's
Deep
a lot
dive.
to talk about.
Yeah, I
Yeah,
would say
deep
so
dive
too.
on that.
Yeah.
Yeah. Awesome. That's awesome, though, to give people just an idea of what can be done and what is being done and what you've been seeing in your pile. So that's amazing. Nature always has an answer. She's
Yeah.
she's a
And this
bad.
organic hippy
Yeah, it
trippy
has
stuff can be
Yeah.
very
multiple answers.
science, you know? Mm-hmm.
Yeah.
Yep.
It has redundancy. You know, when
Yeah.
when the
Definitely.
answer's wrong, she's got another answer.
Absolutely.
There's lots of
Always an
stuff in
answer.
there. Those
Yeah.
compost piles are huge reservoirs of microbes. Huge. That's what I can tell you, right?
Yeah.
So the future of this industry is insane. The potential of the future of studying compost for microbes and using it as a bioincubator to grow microbes has, it's not even begun.
Right.
Yeah,
I
no,
don't think.
totally.
I agree.
It's interesting that we're on such, we're working with however old these organisms are, whether it's 2,000 years or 3 billion years. We're working with an extremely old system, and we're literally, it feels like, at the very beginning of it. Dr. Lane's been trudging through since the early 90s. I don't think it really caught major steam until into the 2000s, and it seemed like 2012 to 2020 was a pretty good exponential jump up in the actual awareness. Not people just mentioning that they're doing compost and whatnot, but like actually following the protocol. We're just a handful of years in to people legitimately applying what Dr. Lane's actually talking about. We've got a, you know, whole bunch of,
It's hard, right? It's
yeah,
hard.
Yeah.
it
Yeah.
is. It is. So it's, with any new technology, there's, I don't know if resistance is the correct term, but it is a journey, so to speak, to change people's minds completely about this. And especially now in our cannabis work, we're starting to see a lot of hydroponic cultivators move into living soil, and oftentimes they want to bring a lot of hydroponic context, which actually makes it very difficult to make them be successful. You still can make them be successful, but if their mindset doesn't change, then they usually don't have success. So I don't know some of the things that you've seen in your journey starting this. Dr. Lane is here. I honestly don't know. It sounds like if there was only one Soul Food Web advisor in Daniel, it's you're really in the infancy. What has that been like introducing these legitimate scientific concepts to organic farmers, or even you've got some chemical agriculture farmers that are
It's
interested in making this transition. What has that been like?
Yeah, yeah. That's where for us, Daniel's whole goal is to transition conventional farmers to a biological system, right?
Right.
Making it kind of organic by default, you know, um, just because it's high efficiency and you get the same yield and you sequester carbon at the same time. That's the goal, right? So we're going for the conversion of conventional farmers. So you know, there's lots of people that just they don't have the reference point and they don't take it seriously.
Yeah.
I guess deep down, a lot of people know that they go to the woodland and the woodland grows, but an agricultural system for the last 100 years has been quite different to nature. You know, it's not really a natural system, and we don't expect natural things from it generally.
Right.
So, you know, to take Elaine's wisdom and some of that Masanobu sprinkled on as well, you know, for your individual situation, um, yeah, like it's hard work. It's hard work, and it's a long road to that point, and it's not as if it's one system either. It's like a transition, and then kind of like finding a balance within this new system, right? So it's I strongly believe that the transition will look a lot different to the systems we can create in the future, basically, you know, as the systems mature. Because if the management is correct, you get maturation, right? You don't get this
Right.
constant deconstruction of the environment. So yeah, so how our whole game is to prove it beyond reasonable doubt and publish it for the UK, because you can show conventional farmers in the UK a soil food web case study from America. They're like, we don't care, you know, we don't care
Right.
about that. That's not
Right. Right.
this soil. That's not my situation.
Right.
So
Right.
we kind of need to prove it beyond reasonable doubt to UK farmers. And I think we do that at least like 3 or more locations, and we document everything, and we do it with, you know, chemistry and biology, the DNA and the microscopy and the plant sap and um, every metric that you can get out and in the field and count, you know, everything. Put a time lapse video on the field, you know, look for bird activity around the side with biology on. I think I saw it, but you never know if you're biased, right?
Right.
So if you take down all these data points, eventually you can see you're not biased, you know,
Right.
that it's in the numbers. Um, and so, yeah, so trying to communicate this to people has been quite hard. They're either, you know, they totally believe it and they don't need evidence, or, you know, no evidence is possible.
Right.
It's like one or the other, really.
Totally. Yeah. But try to show me
So you
anything.
need to
Yeah.
have it on a big piece of, you need to have it in a paper, in a series of papers. You need to make publicity about it. There basically needs to be a Tesla of compost appear in every country that I think this is how it's going to have to go, because you know we've seen grassroots shit and it's cool and it works, but it's very small and it's very kind of suffocated by the outside world. So we need a
Yeah.
big Tesla corporation to come in, understand compost, and make a system for farmers that works beyond reasonable doubt. Um, so that's the kind of company we'd like to become,
Yeah.
basically. You know, before the electric car was made by every company, Tesla pushed it, right? They
Right.
Right.
create demand for it. So without the access to biocomplete compost, or whatever you want to call it, ecologically functional compost is what I've been calling it myself, but
Nice.
Yeah.
I
Yeah.
guess it
Nice.
doesn't really matter. Compost that serves a purpose and supports a crop, right?
Yeah.
That brings in carbon-based life, so we can sequester carbon. Um, yeah, creating a compost like that and applying it to a, a farm at scale and actually trying to do it biologically is going to take billions of pounds, I think. And
Yeah.
but is what we have to do.
Yeah.
It's what we have to do.
Definitely.
And so yeah, I think we can do that. So if you're rich and you're out there, come give us money. People have been doing it and it seems to work. So um, guess what? You know, like you pay someone to do a job and they care about it and it gets done. It does
It
get
does.
done. So we need to do that job. Um, but yeah, it's been hard to convince people, and then sometimes it's super easy. They're
Right.
too convinced. They're like, I
Right.
want
Yeah.
my whole farm to be soil food web now.
Right.
I'm like,
Yeah.
well, Daniel and
It's
Elaine have been good in their influence of saying, no, wait, let's just
yeah.
do a little bit and let's see how it goes, and let's modulate our behavior and see what we can do on a small bit, and then we'll scale it up.
Yeah.
You don't have to like be the sort of food web right now, be the mature system right now. You just have to start collecting data and move in that direction. So that's where
Yeah.
we're at now with farmers, and now we're seeing big corporations take notice, right? And when they go and the money comes in, then that's when it all happens. So it's an exciting time for
It
us.
is.
It is.
It
Yeah.
is.
Unfortunately, we can't grow wheat, but
Yeah.
we can grow black currants.
Right.
Nice.
I heard black currants got terps, so that's cool. But yeah, it's we
Yeah,
run into the same type of thing with that was the best line, man. No evidence. There's no evidence that can change their mind, even if it's in front of them. We've
Yeah.
had people that it's right in front of you, and they're still like, this is hogwash. It's like, well, then it's hogwash. But I think a really important point you
yeah,
made was start slow.
Mm-hmm.
Piece off a part of your property that you can afford to learn on and spend a couple harvests learning what this new system will require of you. And then once you get those foundational principles, it's very easy to transfer to the entire thing. But, it's, you know, it's interesting that the obstacle of some farms is that they can't be convinced. And then another equally problematic obstacle is people that are so convinced that they hastily jump into something they don't fully understand, that they're behind. And it is,
yeah. I'm
it
going to
is,
remove all the fungicides and I'm going to
right.
apply nitrogen, but I'm just
Yep.
going to do loads of compost teas.
Yeah. It's like,
Yeah.
And like now you're making a recipe for disaster.
Yeah.
Like
it really is.
stuff
Yeah.
like that.
Right.
Yeah.
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 It really is. What are, oh, good.
Oftentimes it can be hard to just even keep the control because of they see such good results. They're like, screw it, and they don't want
Yeah.
they don't want the rest of it to, they just want to convert everything. So then you lose your control. That's often what happens.
It's very hard
but,
to,
Yeah.
yeah, it's very hard to get a farm to maintain a control in our experience.
Yeah. But
But yeah, you've had some
From
very
people's
interesting,
perspective, for us, it's like they think you're trying to run a farm with a biostimulant, right? At best, and that's kind of true in a way. You are trying to run a farm with a biostimulant, you know. From their perspective, like the compost extract, they see it as this word like biostimulant, right? They
Mhm.
don't see the meat and potatoes of it, and the nutrient cycling, and the endophyte cycles, and all this beautiful stuff that's going on.
right.
And it's also really hard to get that stuff established in these systems.
Yeah. It comes from that reductionist mindset. Everything has to be reduced down to one thing, and nature never really is that way.
Yeah.
So it's kind of changing our evolution of thought into more matching what actually is happening in nature, and it's a beautiful thing, right?
Yeah, and people try to
Yeah, like that
ditch.
pattern recognition stuff
Yeah. Mm-hmm.
that you're talking about. That feeling, looking at the data, seeing the matrix is a good feeling, right?
Mm-hmm.
It's challenging. It's like steering a ship or something, right? Through this weird climate thing, or just yeah, it's like steering this big ship, and it's kind of fun when you start to see the patterns in the seas. It's
Right.
interactive and it's cool.
Yeah.
Yeah,
Well, and it
It's
forces,
different. It's dynamic, right?
yeah, and it forces us as humans to acknowledge the beautiful tapestry of the nature that we live in and how interwoven it really is. And there's backups on backups and duplications. And, when you're trying to break down something, nature gives you that organism to break it down. And it's just I think it's a
Absolutely, yeah.
wonderful thing. And I think that hopefully we'll see that. And I do think that we're seeing that evolution of thought and the way that we behave in the environment, though it's faster for some of us and slower for the masses, I think, but we'll get there hopefully before we fall off a cliff. So
Yeah. I think
if it's not too late.
there's a big, well, maybe it's not massive, but there is kind of this surge of people in the UK becoming more interested in this stuff for sure. Just generally, like worm bins and composting and local kind of resource collection, like local composting clubs and stuff like that. Maybe I've just been more exposed to it though, and it's probably really tiny. But
Well, it's something and it's
I think
growing at least.
Do do they capture green waste from your trash separately? I mean, I don't. Again, I'm a silly Californian. I don't even.
it's kind of
I'll,
different around the.
yeah.
It's kind of different around the UK.
Mm-hmm.
Um, yeah, so they do compost some gets incinerated, some goes to landfill. It's got a mixed bag of stuff going on.
Mm-hmm.
Um, and the compost, we're situated on a green waste site to take. We're trying to take green waste matter, the raw material. The farmer takes that, sorry, gets a gate fee. We're trying to take the best of that. So we
Mm-hmm.
take the best of the best stuff and we make like a cool compost pile where we monitor it differently and we look after it. And that's kind of the model, right? So to utilize existing green waste facilities, optimize the process, move into them, and then and use that. So most of the stuff we're using is garden waste. It's just kind of wood chip. I use a lot of coffee from the local farm shop, and that can be scaled up because you have lots of coffee brewers around, like
Mm-hmm.
dirty instant coffee being made. There's huge resources of coffee out there. It's granular. It's like really granular, so it mixes into the wood chip really easily,
Mm-hmm.
super easy because it's just like mixing an amendment, right?
Mm-hmm.
It's acidic. It doesn't cause this big boom of oomycetes. It seems to select against them, and it seems to speed up um, succession towards kind of fungal ecology, um, and then use hay from an unfertilized field, just a little bit of hay, 10% hay. So we do that to try and bring in some endophytes that will be, the spore forming bacteria endophytes that when you dry hay, you might kill back some of the stuff that doesn't form spores, but the stuff that forms spores will go to spore in the tissue. And then so we use a bit of that. So I think it's obviously a green, but it kind of adds more than just it being a green from a hay from an unfertilized field. You get a bit more added bonus, I believe. Um, so we don't
Nice.
really have a true high nitrogen input for our composting mix at the moment, and it kind of works better like that, I think, and just add more on the successive turns of coffee if you need it.
Hmm.
Um, yeah, so yeah, starting to make a cool mix that seems to manipulate the biology. This is the cool thing about using the microscope, right? Taking
Yeah.
down, like writing everything down and recording everything, is that you can see what mixes turn out to be better, and then you can start to understand why is this mix better, right? Why is it more aerobic? Um, are the materials somehow, they better fungal foods? Is it creating a better environment somehow? And then we might start to see useful ways to manipulate this material.
Hmm.
Like I just mentioned, we found out with the coffee. So if you use something like they love going to oats or something.
Yep.
People need to add or seeds. And if you go to seeds and oats, you seem to get the proliferation of more um, organisms that Elaine teaches, you know, are more likely to be disease-causing organisms.
Hmm.
Right.
Interesting.
So using and seeds probably aren't a very good input when you're at scale and you're in a green
Right.
waste facility. You're not usually going to
Yeah.
be receiving loads of seeds, but you can receive
Right.
coffee, right? They've
Yeah.
already had some of the energy taken out of them by brewing the coffee. They've been fermented, so there's a bit of metabolite there. There's kind of like it's been broken down a little bit through some kind of enzymatic hydrolysis from the fermentation.
Yep.
And it's also acidic and it's granular. So I'm a big proponent of coffee. I think you should all
Hmm.
get coffee, start
Huh.
making compost with coffee, and then
Hmm.
come back to me and tell me what you found out. Because
Okay.
like everyone out there, reach out to me, Instagram, soil ecology, agriculture. Um, yeah, so it's it's worth checking out. You can
Nice.
because I'll crack on a bit for a bit longer about composting,
Do it.
but you can we found this is really practical stuff for soil food webbers out there as well. No one else will care because it's so geeky, but you can use the nitrogen, the nitrogen in input. The nitrogen input can be used like a dial to turn up the nematode number at
Mm-hmm.
about 30 days in, right? So
Mm-hmm.
you can crank up nematodes a month into the thermophilic process by increasing the nitrogen to a certain extent, right? So
Okay.
the mix that Elaine teaches people is generally to start make like a general mix so you can kind of hone it to your situation. 60% carbon, 30% greens, 10% high nitrogen, right? So if you increase that high nitrogen percentage, you can start to turn up the level of nematodes a month in. The trouble is you start to select for microbes generally with high nitrogen materials like manure or seed meal, stuff like that, and you get this big kind of omycetes like
Yeah.
population generally. We do, right?
Mm-hmm.
Whereas if we flip that to coffee, now the omycetes go away. And if you look on the Olivia Husson graphs for
Yeah.
redox potential in soils, you'll see that omycetes and beneficial fungi are in a different area of soil,
Mm-hmm.
right? They're in a different kind of pH, EH range. So maybe by manipulating the redox environment of our um, compost, we can select for groups that we want faster and select for groups, select against groups we don't want. Um, so that speeds up the development of the succession of the compost, which is going to be important at scale when we're trying to deliver this to a nation, right? We'd like to deliver
Mm-hmm.
it nationwide. So, or
Right.
at least 50, Daniel's goal is 50% of the country covered in compost, covered in
Right.
biology. Um, if you go from David Johnson's figures for carbon sequestration, which are kind of outliers, but nonetheless, they are figures that have been written down. Um, I think you can sequester 100% of UK annual carbon emissions on 50% of the agricultural land in the UK. To do that,
Hmm.
you basically need to understand how to grow grass. That's the only thing you need to understand.
Right.
That's that
Right.
whole area pretty much is just grass. It's wheat, it's barley, it's pasture. So all
Right.
we need to do really is figure out the biology that runs a grassland system, and we can do a lot of damage. We can
Hmm.
sequester a lot of carbon.
Well,
And if you don't believe in needing to sequester carbon, you can think of it as building soil, right? No one can
yeah.
argue that
Right.
we don't, that, no one can argue that we don't need soil. We need to build soil,
Yeah.
and building
Need
soil
that
is
filter.
sequestering carbon. So
Yeah.
You're
Do
going to
you?
want to sequester some CO2 in case you weren't wondering. You're going to
Yeah.
want to do that.
With some carbon taxes and all that stuff coming
probably
down the European pipes, it's going to be important.
it's a
Yeah.
complex issue, though. I
Very.
give people who say it's they don't believe it. I give them that. It's a
Sure.
complex issue,
Yeah.
but it's nothing complex about the fact that we have to build soil, or
Right.
our civilization will collapse.
Yeah.
Exactly. It's pretty.
I mean, that's how the Roman Empire took over the world, is they messed up the farmland by adding salt to it. So
Yeah, they
it's
salted the
Yeah.
ground, right?
pretty genius that that's our first
For you
line of
chemistry heads
offense.
out there, they just upped the sodium. They upped the sodium on the base saturation.
Just raised it up.
I know that because Scott taught me how to do that.
Nice.
Up
Yeah.
the sodium, and you destroy the civilization.
Yeah. No biggie. But that's a whole nother session on its own. But yeah, man. Do you have any interesting questions for our guests here?
Well, I was just going to ask
Mm-hmm.
you, based on all of your studies and research and results and all that stuff, and just doing it, making all this compost, do you have a favorite method that you prefer? I guess it would probably depend on the scale that you're
No, I
talking
think
about, but
everyone needs to use all methods personally. I think at scale, to achieve the thing at scale, you don't achieve it as biocomplete compost, right?
Right.
You achieve it as biocomplete composts. And
Mm.
I think a compost pile at 4 months in, 3 months in, right? And a compost pile at 10 months, 12 months in, and a compost pile at 16 to 24 months in, they're all different ecologies,
Yep.
right? They're a succession of ecology. And as you think of it a little bit like soil horizons and the mulch layer. When you put a compost pile together, any of them, they are like a fresh mulch layer. And as you progress in time, it's like going down in the mulch layer, right? And then you
Mm.
start to hit the interfaces between the soil and the mulch, right? And then you start to hit the mineral soil. And so as a compost pile successes, it basically just becomes humus.
Yeah.
What we should call most compost that's sold now, I like Neil Kinsey's definition of, we should call it manure, because it's
Mm.
not really compost. It's more like an artificial manure
Mm.
in its kind of carbon to nitrogen ratio, and the fact that it's kind of full of excesses of potassium and stuff like that. And as it successes towards humus, it becomes like this beautiful thing, that becomes like more ideal soil chemistry, and all those excesses go into, or most of them, they go into microbial ecology if it goes well, and you get this beautiful alchemical process. Um, but no, I
Nice.
don't think we should use one particular thing.
Right, right.
I think we should use lots of processes, because there might be ways to say, a good example right now I'm thinking of is you capture farmyard manure. If you aerobically compost that, usually it makes pretty bad compost, right? Pretty bad aerobic compost generally, the
Mm-hmm.
farmyard manure stuff, where it's just manure and straw.
Right.
Yep.
Um, so if you could maybe use a Bokashi process to preserve the nutrients within that, stop the losses of ignition, um, and then you could put that out on the field, providing you've done a soil test and you're not going to like bump up any excesses. If it makes sense chemically in your environment, you can capture a lot of nutrition. You can put it out there in the field, and then you can follow it with an aerobic extract, right? And you can try and
Mm.
get that aerobic mineralization happening. Try and increase your aerobic um, zone of your soil. And you've used two different processes, but you've understood them, and you
Right.
know the context to use them. So yeah, I think they're all going to be useful, but I like interacting with thermophilic compost. Like I like flipping it. I
Yeah.
like making it. I like going to work and have it, make a pile. Feels good. It's like an exercise.
Mm-hmm.
Hmm.
I feel like a pile made like that, where you achieve, like I talked about earlier, you achieve these higher nematode numbers.
Mm-hmm.
Um, then also taking that one and then mixing it with something like a Johnson Sue that went well.
Yep.
Now you've got like a fungal system with a fungal feeding nematode in it. You've got some arthropods munching on fungi, and then you got this like fresh system that's got like 100 nematodes per drop. It's got loads of amoeba in it.
Yep.
And you've got like a cool mix of stuff, and you hit those numbers that the school teaches you are a minimum, or
Mm-hmm.
Right.
they
Yeah.
may be somewhat of an arbitrary goal, but well, I don't know the research that went into them, honestly. But
Yeah.
Right.
you know, the more the merrier, and
Sure.
in relationship to your plant, So
Mm-hmm.
Observably, it does seem to be, I mean, at least with our work in the last 7 years, those do seem to be the minimum to achieve like stability in immunity and
Yeah.
things like that in the system, and that the plant is actually getting what it needs. But we do see that there is a higher threshold of those biological minimums. It can go much higher than that and still be even more healthy. And a good example of that we often will show is
makes
that
sense.
yeah,
Mm.
is that
Yeah.
Johnson Sue or David Johnson when he does the F to B ratio of the bell peppers,
Mm.
and their minimum, or what she has as where they lie in ecological succession, is more around the 0.7, 0.8 F to B ratio, I believe. But you can see that they don't, it's not like they suffer. They have they have even better health, even with even more fungal component in there. And I believe that that's just what we're going to see shake out is just kind of different thresholds. But I think we have to start somewhere, and we have to at least. I mean, we're dealing with dirt. There's most of these soils are so depleted that even just getting to those thresholds, those ecological minimums, are going to be mind blowing. So, yeah, that's what we see.
Yeah.
Anyway.
Yeah, it's definitely a good roadmap to start on, for sure.
Yeah.
But like in our cannabis work, for example, if you really want to get rid of all the bugs and blow your mind, you clearly need to go to higher levels of nutrient cycling and higher levels of bacteria, which doesn't seem to hurt most plants. You
Yeah.
know?
As long as it's stable,
Yeah,
functioning, all the parts are there.
I think I found that with the DNA stuff, possibly that a really cheap way to be able to up that faster is just to increase the bulk density of the material. I don't know if you guys have found that, but
No.
as you generally increase bulk density, you find more surface area, and I think you can load more stuff in there quicker, if that makes
Interesting.
sense. So in the abundance like figures for the different compost that we've had analyzed with DNA, um, they they just have a higher abundance of like gene signals. So I
Interesting.
feel like that is a cheap way of. Obviously we can't do that for commercial substrates because it makes it too heavy to like ship around. But yeah, it
Hmm.
might be a cheap way to up that faster.
That's interesting because we do
I
see
find
like.
with
Go ahead. Yeah. Mhm.
with the the substrates like these kind of living soils they get called, right, which is funny because they come and they're not really very alive
No.
Yeah.
and they're not soils, right,
No.
Right.
they're
No.
organic matrices that approximate soil minerally at
Yes.
best,
Yeah.
you know.
Yes.
So it's kind of strange the language, but yeah, like I find that when we're working with those growers it's hard to get the numbers up, yeah,
I would agree.
like we tell them to. It's hard to get those numbers up. So you really have to use every trick in the book and you have to pay attention to what makes them happy, makes the microbes happy on the microscope, or it's just not going to work. You know,
Yeah.
it's going to, it's hard. It's hard work. So I commend the people that do that and you guys for doing
Yeah.
that. You know, that's,
Thank you.
I guess I always chalked it up to on the lighter weight soils that was typically a more hydro based mindset, and the lighter weight soil just had more erratic wet dry cycles, and maybe that was keeping the biological populations lower. But I didn't even think about surface area. Like
Makes
it's
sense.
just it's
yeah, I
a
think it's
smaller playing
completely,
field. Yeah. Hmm.
yeah, and also
Fascinating.
biofilms, right?
Right.
Biofilms. The colloids will, I think they'll create biofilms faster.
Hmm.
They'll help create biofilms faster. So when you get your living soil, you might want to get some clay, some good humic acid, or some a mixture of those things, and then apply that, with the biology and try and build biofilms. Maybe alginates might be good too. Um, what we found maybe is wetting agents probably not as good. You know, they're a bit harsh on the biofilms, and that's probably the key reason you shouldn't use them.
Right.
Possibly.
I haven't seen one be all that spectacular, but god dang, they're popular.
Yeah.
But
There is one actually.
yeah.
There was one I tried and it worked, and it's a science-based company. Don't even mind mentioning them. They're
Sure.
what they call Grow Genius,
Hmm.
and they do a monosilicic acid product, and they do a wetting agent, and it didn't. Um, it actually boosted the flagellate population. It didn't destabilize anything, and it. I think it is an oil that's been processed by a fungi.
Hmm.
I forget the sciencey words, but
Hmm.
um, it's turned into a kind of a wetting agent by a fungi. So it
Interesting.
doesn't seem to have those effects. It doesn't seem to have, at least in a short-term trial, it didn't have any effects on the biofilms as far as I could recognize compared to
Hmm.
the control. And it even boosted the flagellate population. And I believe that was because it because it's a wetting agent, because it makes the water go into the kind of micropores, and
Right.
flagellates, I think, are stimulated by that kind of moisture.
Nice.
Yeah.
There's a
They
new
seem
one
to
in the
pulse with moisture. I don't know if
Yes,
totally.
they do. Yeah,
I don't know if you
totally
guys see
agree with
that,
that.
but they like the populations pulse with moisture. So a watering event is a biostimulant for a flagellate, right? You
That's
get
right.
Right.
some
Yep.
flagellates kick off. So
Yep.
Right.
I've
There's
often seen like really dry soils when they arrive, they're very dry, and then when I let it sit for just a few minutes in the test tube, now
everything
I've
wakes up.
they wake up. So it's yeah. Yep.
Very good. Well, I think we're getting close to our hour, of which we normally try to aim for this show. Do you have any last comments or questions you'd like to ask our guest, Miss Sarah?
No, I'm good. I'm happy that you're here with us, and thank you so much for being
Yeah.
here with us and just working with us. And I'm just happy to have you on. I can't wait for the next episodes to dive deeper into this stuff. So
We appreciate your
it'll be
cheeky
fun.
British humor.
yeah,
So where can
Yeah,
people get a
and
hold of
it's
you?
great. It's great to be here because you guys, I saw you guys on maybe Future Cannabis Project
Mhm.
or some other shit,
Mhm.
and yeah, instantly you were a big help at the start
Mhm.
of it to try and wrap my head around it. Not chatting shit basically, and just giving your truth, which was very helpful to me.
Mhm.
thank you, thank you.
That's all you
Appreciate
can
that.
do is speak your truth, you know?
Well, you
So,
always hope that you reach people, and then just the fact that we're reaching people as cool as you, and to be able to help you on your journey, and then look at all the things that you've been, doing and sharing, and now, sharing back to the
Absolutely, yeah.
community. That's
yeah.
amazing. So
Yeah. So
thank you.
next time you have
Yeah, we'll
next
dig into
time.
DNA and
Yeah. Yeah.
Sorry. Go
Yeah.
ahead.
we'll dig into that, and we can go through some of the data I've got on, maybe turning that nematode key, turning that dial and cranking it up, because I think that's really useful, right? Stuff like
Mhm.
that. It literally makes a compost 100 times more useful. If you have,
Right.
Yeah.
if the minimum is one nematode, that's what you got. Don't be happy with that minimum. See where you
No.
can
Right.
go, and try and make sure that they're not horse killers.
Yeah, because that's
Yeah.
what happens if you get the wrong ones.
Yeah.
Yeah,
Little,
yeah, and that's a good message. That's a good message too, and maybe we can go into that.
yeah.
That when we get microbe happy, we maybe forget about the pathogens, and the pathogens are a big learning experience for me during this. I think the pathogens are great teachers, even I'd say that,
Yeah.
Yeah.
and we can go
Yeah.
into that a little bit maybe.
Yeah. The
Yeah. I
little
love that.
teaser is Adam did some tinkering increasing nematodes and through DNA testing found out that some of the popular techniques actually make very problematic brain parasites. So make sure
Well,
that
that
Well, they can
you.
do, yeah. A mesophilic pile is a powerful thing. A mesophilic pile is an incredibly powerful thing. You really do want to make sure you at least put a thermophilic process in front of that mesophilic pile, because if you play around with those mesophilic piles, shit can happen, right? It's no joke.
Yeah.
Yeah.
There is shit in the thermophilic piles too, but
Yeah.
you're just removing that. You're removing some of that danger, and then
Yeah.
as you go on to like Johnson suet or put worms in it, put beneficial fungi in it, get the King Stropharia out. Now you're really cooking, and now you're really getting rid of the parasites and the pathogens. So yeah, so
Nice.
it should be respected.
Yeah.
It should be
I,
respected. The
I can at
compost.
least say anecdotally that once people follow certain trends, they behave like they got a horse brain parasite. So yeah, I would say that the anecdotal evidence is true. But on that note, thank you, for joining us. We'll definitely have you back on for other sessions. We really need to dive into some of the wild things that you've done with DNA testing and all your pile tinkering. You know, we did a lot of tinkering early on, and when we found something that worked, we just wrote it out and just try to perfect other aspects of it. And I think you went down a completely other hallway of what happens if I just radically tinker with this pile. And so you've done some very interesting things and had access to DNA testing
Yeah.
and disciplined organization and documentation, which is where the real understanding, I think, of the process comes. So with that, if you haven't caught so far, for those of you watching, this wasn't a live one, go ahead and drop your comments and we'll respond to them in the comments if you've had some questions along the way. And then next time we have Adam on, we'll do this at an appropriate time for our British folks to tap in. So
Do you want people to be able to find you and reach out to you in any way? Or
Yeah, you can get in touch with us at Soil Ecology Laboratory. There's a website, Soil Smith's website, or Adam at Soil Ecology Lab
Excellent.
.co.uk. That's for
nice.
everything biology, and then also Soil Solutions UK .com. That's for mineral balancing. So
Nice.
Awesome.
Nice. And we'll
and
throw all those in the
IG
comments.
Soil
So
Ecology Agriculture.
yeah.
Okay. Okay.
Yeah,
Awesome.
cool.
And we'll drop those in the comments for those of you watching the video to check in with our guest. And with that, we'll thank you all for joining. Thank our guests for tuning in the middle of the night, I think it is. And until next time.
It's not that late yet.
Right on,
Take
guys.
care, Adam.
Thank you.
See you next time.
Peace.